This is a Sonoluminescence instructional video by Noah and Ryan.
You have to degas the water before it's usable. If you don't get all the gas out of it, it won't form bubbles. The way you do that is you boil the water for about 20 minutes. Then you cork it, then you should let it cool to room temperature. Water has been boiling for a while now, so what we can do is we can shut off the hot plate and take it off of the hot plate. It'll be hot, so make sure you're wearing your special glove, and you should cork it because it will regas as it cools if left open. And then we can either leave it for a while to let it acclimate to room temperature, or you can take it to the sink, run some progressively colder water over it. You want to be careful, it is Pyrex, but best not to put yourself in danger.
That we use to record the bubbles that we form. You can change the different things by, like, here's the focus and here's the brightness, so you can dial in on what your bubble looks like and get a good video going. This is attached to a digital camera which feeds into our laptop here. We use this app here called IC Capture 2.4, which we have open here. And the way to get a video recorded is to go to Capture, go down to Toggle Recording Info Dialog, and then you can change a name of a bubble by going to this tab right here and clicking on this button, which allows you to type in whatever name you want for a bubble or whatever you want your video to be. Then you can save it and press OK, and then you just start recording by pressing here, and then you stop it by pressing here, and that will save to your computer for future use. Here's the voltage on the generator here. Click on this button, it should send you the high level. You can move over with this button, and you can change the voltage between whatever you need to. This voltage is going to be amplified by whatever you do on the amplifier, so just try to keep it below 10, it's the maximum. Generally keep it 6 or 7, and then change it with the amplifier itself.
You do want to avoid negative voltages. If you alter this low level, it'll change the offset to make sure that it's at 0. You can see we've put tape over all of these lights. This is the power. It'll indicate that it's on. We made covers for that because when you're looking for sonoluminescence, you want to take out the light pollution from it. Anyway, this amp will amplify the signal from the function generator, so it's higher voltage, and you can adjust how much it amplifies with this gain. You'll have to change the gain with the screwdriver. There's a screw in there. And you want to avoid going over 1000 volts here, or else you'll risk damage.
Oscilloscope. Power button's on top. Turn it on. Takes a second to boot up. This is going to read the generator's amplitude through the amp coming through, and it's also going to show the waveform of the frequency. So you can see here right now, we have a volt peak to peak of 160 volts, so this thing only has about 7 volts coming through, so it's being amplified to 168 through the amplifier, which you can read here. You can see the waveforms of these waves that are coming through. So if you were to change the frequency, you can see how the waves start to change, things like that. So you're going to want to pinpoint where your sonoluminescence bubble is by looking at these waveforms and finding the correct one. And you're also going to want to look for this peak-to-peak voltage right here to go up as high as you can. The higher peak-to-peak voltage you can get, the more likely there is sonoluminescence in your flask going on. We're going to read these two different channels. Right here we have channel 1, and this is channel 2. Channel 2 has the function generator and the amplitude coming in to the oscilloscope to read, and this channel 1 is reading a pickup mic on the bottom of our flask, giving us this peak-to-peak voltage. You can change the scale of things on your oscilloscope with these two knobs here. If you want to read things differently or see them in different sizes. You can measure different things by clicking this measure button and going up and down this menu board to kind of get different options, whatever you need to do. It's got a lot of options. You're going to kind of have to tinker with it and figure it out for yourself, but it's pretty self-explanatory. It's not too hard to turn off the menu that way. In worst case scenario, you can always press this auto button, which will kind of give you a pretty general range of what is coming into the oscilloscope at the time and kind of get you pretty close to where you want to be. So worst comes to worst, just press that button and you should be pretty safe.
About safety, we are in the range of current and voltage that can do some damage. So when all this equipment is on, try not to touch, bare wires and such. And if you, for some reason, you got to touch bare wires, you really shouldn't. But make sure you're doing it with just one hand so that the electricity won't take a path through your heart and, bonk you off. A note again about the voltage limitations on the amp. You shouldn't go over 1,000. You can see on channel 2 here we have a peak to peak of about 210. You want to stay pretty low. And also on the function generator, you shouldn't be running a wave that is, significantly higher than this, because you risk shattering the flask. If you go too low, you'll start to hear a buzzing. That's just because it's going in the range of, human hearing. That's not good either, but it's not going to break the flask, and you really shouldn't be down there anyway. So, safety note, the capacitors will take a while to discharge, so even once you turn off the system, make sure that you wait a little bit to handle it. And also there is a danger, we're working with water, of spilling water on this. Just try not to do that. You risk any number of things.
On the flask attached are these two PZTs. They're capacitors that hold the charge coming through, and will actually send the wave through the water here. And there's a little probe on the bottom that we have wired in, picking up the signal of what the waves actually look like going through this water. And you can see it on the oscilloscope. That's what's going into channel 1. The PZT is made out of a crystal. I'm pretty sure it's quartz. I'm not completely sure, but I know it's not regular glass. Anyways, the water level is very important here. As you can see on the oscilloscope, we have these waveforms being generated through the pickup mic. You can see them. And when you take water out of the flask, you can see how the waves will start to change. So you have to kind of find that magic point where your peak-to-peak voltage peaks high, kind of like there. You kind of get the hang of it yourself. You'll see that there's a couple points where it'll peak, but there's definitely a spot that it peaks the highest at. So just be careful of that and try to keep it right at that level when you're testing for bubbles. Variables that are important in this experiment are temperature and pressure. So to find temperature, we have either this probe temperature where you can just turn on, stick in your water, and it'll give you a digital readout of what your temperature is. Or if you're feeling rather lasery that day, we have an infrared laser here that you can shine into the water and also get a temperature reading. So just try to mark that down before you start testing bubbles so that we have some data on it. And we also have this barometer here on the wall that gives us the pressure in the air. You can see right now it's at about 1040 HPA. So yeah, just mark that down before you start taking bubbles because it is a variable that will affect how sonoluminescence forms.
If we properly degas the water, we should hear the cork make a big pop when we take it out. And we do. Perfect. And so we have this handy, very high-tech funnel. I'm going to put that on there and fill up this flask. It is important how much water is in the flask. In general, you want the water to generally have a spherical shape. You can see I overfilled it just now. You can see it's up the neck of the flask a little bit. We'll have to take some of that out. How much water is in this flask will change the frequency and such that you need to adjust for. Because you can't perfectly control temperature, pressure, and water volume, you're going to have to tune your function generator a little bit. You can see on channel 1 down here is our output mic. And what you want from that is you want a waveform that kind of approximates this input waveform. So you can see here, we're getting kind of a peak there, if we go over it, you can see it start to go down. If you go really far, you can see it start to get even way different. So you want approximately the same waveforming, and you want it to be as high peak to peak as possible. Sometimes there are a couple peaks right near one another, and that can fool you. So you want to be careful about that. You want to scan kind of around where you think it is. So here we're kind of finding a peak here. You can see me kind of fine-tuning it, so see where it starts decreasing. Well, about right there. It's pretty good.
Light you're going to get from the sonoluminescence bubbles are going to be, it's going to be a very small amount of light, so it's almost impossible to see when the lights are on like this. So over here on the wall, you can see where the light switches. You can turn them off and on. And then over on this wall, if you want to use a lower intensity light source while you're trying to find the bubble, you can hit this button, just pop it on. It'll turn these green lights on, which you can see are much darker, but still able to work in. So when you're actually finding your bubbles, it might be useful to use the green lights rather than these bright floodlights.
Alright, so we've got all our stuff set up. We've tuned our frequency generator, and it's particular about the water level in the flask. So I'm actually starting a little bit low, and I'm just going to add some drops in, and within a couple drops it should kind of catch. Almost there. Now you see when a bubble gets trapped in there, you should see some significant distortion on the output line. If we look at our camera, it's small, but you can kind of see bubble, and we're going to turn off the light. And if you look close, you can see bubble right there. It's hard to see with your naked eye. You can kind of do it. I don't think it'll show up on this camera, but if you look through the camera, you can see it pretty good.
As long as the bubble is still trapped in the flask, these lines will be distorted. So he's going to stick the dropper in there and kind of disturb the water and pop the bubble. So you should see it pop on here.
Mm-hmm. But I can find the flask in the dark. There we go.
And there goes the bubble.
And you can see the distortion.
You can see that the distortion is gone.
Once we've finished for the day, you should make sure to turn everything off. So your oscilloscope, your function generator, your amp. And you're probably going to want to use new degassed water each day you do this, because even if you cork this jar, it could regas, and it's best to just have a little bit more control over that. It's hard to dump the water out because the flask is affixed. So what we generally do is we have this little squirt gun, and you put that in there, and you just get it going. Yeah. Make sure the hot plate is turned off, everything is turned off, and make sure, remember to not touch bare electrical components until it's been off for quite a while, because they can still have a little bit of charge in them.
A little bit of a process to get the water out, but
yeah,
it's easier than taking it on and off.
It's kind of fun. Get your finger exercise going for the day. And if you have a little bit left, it'll evaporate.
And we'll generally use new deionized water when we boil it. We don't usually use the water that we used beforehand, just because sometimes there's particles and dust and things that'll get in the water.
Right.
And they show it pretty well in the video since the bubbles are so small.
And it is good practice to degas some more water before you leave. Just take 20 minutes, reboil it, and you can just set it down and leave it for the next time, just so you don't have to do that before you can get working.
So that's pretty much it for what we have going on in the Sono lab right now. But there are a couple things that we're planning on maybe doing in the future. One of them is using a different liquid than water. Glycerol is one of the ones that we've kind of pinned down that might work out. So we might try to degas that and use that as our liquid here in the future. Another thing we might try to do is just kind of experiment with different temperatures or pressures, because those are variables that do affect the bubbles. So changing those might give us some different results. So it's always good to check everything. We also have this little vacuum cork that we are going to try to change out for this one, so that when we do degas the glycerol, we'll be able to keep the degassed glycerol in our flask and not have to take it out, because we're going to have it vacuum sealed so that there's no possible way it can get regassed. So glycerol is a little bit more expensive than water, and it's a little bit harder to degas, a little bit more difficult to deal with. So it'd be good to have that, so we only need to degas it once per term. And to keep using experiments after we have that. We're also thinking about doing a different way to disturb the water rather than drops. We might try to put a wire in the flask permanently, and then just have a little toggle switch to turn it off and on to disturb the water.